Welcome to The Explainer. Today, we're looking at a completely monumental shift happening in computing right now. Seriously, a shift so profound it's actively redefining our entire understanding of what machines can actually do. We're asking the big question, can quantum computing power the AI boom? It's a fascinating question, and honestly, the answers are literally changing by the day.
Okay, let's dive right into this. Imagine a specific, incredibly complex problem. It would take one of the world's absolute fastest, most advanced existing supercomputers 10 septillion years to solve it. But an alphabet processor, 5 minutes. 5! The difference between those two numbers isn't just, a simple upgrade. It's a total, complete paradigm shift in processing capability.
And if you're trying to wrap your head around exactly what 10 septillion years actually means, well, it's longer than the age of the universe. Yeah, let that sink in. That is the staggering, mind-boggling magnitude of the time frame we're dealing with here. We aren't just talking about saving a few hours or even a few lifetimes. A traditional supercomputer would literally need more time than the universe has existed to do what this alphabet machine did while you drank your morning cup of coffee. This establishes some absolutely astronomical stakes. We are crossing into a completely new frontier of technology here.
Section 1. Bits versus quantum bits, the processing leap. Let's briefly transition into the underlying mechanics of how this seemingly impossible processing speed is actually achieved.
Now, what's really interesting here is how they work. Today's computers, the phone in your pocket, the laptop on your desk, even those massive supercomputers we just talked about, use binary units called bits, and they perform their tasks sequentially. Think of a traditional computer trying to solve a giant maze. It has to walk down one path, hit a dead end, turn around, walk all the way back, and try another path, one at a time. It's exhausting, right? But quantum computers use transistors called quantum bits, or qubits, and qubits handle data in parallel. They can consider tons of different possible outcomes simultaneously. Returning to our maze analogy, instead of walking down one path at a time, a quantum computer acts like water, instantly flooding the entire maze. It flows down every single path at the exact same time, immediately finding the exit in an absolute fraction of the time. It's a total game changer.
Section 2. Real-world quantum applications. Because this isn't just some abstract math experiment, there's a very real global race happening right now, stretching all the way from Washington to Beijing, fighting for commercial and military supremacy. This technology means drastically accelerated progress across several absolutely critical sectors. We're talking about revolutionizing drug research, where simulating complex molecular interactions could happen almost instantly. It means a massive, massive leap forward for artificial intelligence. It'll fundamentally alter defense strategies and completely transform the entire world of finance. This experimental Google machine and the quantum computing technology driving it sits dead center of all these industries. This is exactly why this matters so much to our everyday future.
Section 3. The chilling physical challenges. Now, we do need to ground the hype for just a second. Bringing this tech into the mainstream has some incredibly severe hurdles.
So the crucial point is understanding exactly what keeps these machines from being everywhere today. We have to walk through 3 grueling physical requirements. Step 1, providing massive power supplies. These machines are incredibly demanding. Step 2, maintaining ultra-cold temperatures. We're talking about keeping the physical hardware at chilling, near absolute zero extremes just so they can function. And step 3, slashing error rates. Because qubits are just so remarkably sensitive, even the slightest environmental interference can cause errors. You really have to imagine these quantum computers not as, sleek laptops, but as heavy, massive, demanding, and highly sensitive physical machines that require extreme physical environments to even operate.
Section 4. The future is narrowing. But here's the thing. Despite those really harsh physical challenges we just went over, the time frame for finding a practical solution is rapidly shrinking. Late last year, Google actually made another major leap. They announced a massive breakthrough with their new Willow quantum computing chip. And what's really incredible about this is that Google stated an algorithm running on this specific Willow chip could actually be repeated on similar quantum platforms. That's huge. It's a monumental milestone showing that these intense physical challenges are actively being overcome piece by piece, and the technology to solve real-world problems is finally becoming repeatable.
Which brings us to this. Google, IBM, and other leaders in the field predict there could actually be a quantum computer solving real-world problems by the end of the decade. That's the hope, and the reality is approaching so fast. Which leaves us with a pretty provocative thought. When this technology fully arrives and completely upends everything from defense to drug research, are we actually ready for the end-of-decade quantum era? Thank you so much for joining me on this explainer, and keep questioning the future.